Now friction. Okay, see, suppose any object or the body is lying on the surface and we apply some force F to the body. Suppose mass of the body is m. Then as per Newton's second law of motion, when we say F equal to ma, then we can write acceleration A equal to F by m. So if F force is applied to the body lying on the surface having mass m, then that body should move with acceleration equal to F by m. But we observe so many times this thing, force is applied, then also there is no motion of the object. Force is applied but motion is not there. It implies that definitely your applied force is balanced by some other force. Then and then only the body will remain in equilibrium, otherwise not. And body is not moving. It is not moving with acceleration equal to F by m, means definitely your applied force is balanced. Now see, here what is the situation? Now suppose we take a block lying on the horizontal surface, and on that particular block we apply some force F in the direction as shown in the figure. And now suppose block is not moving, block remains stationary. So here when block is lying on the surface, it implies that weight of the block on the surface in downward direction is definitely there, and that is equal to mg. So in other words, we can say block exert the force equal to mg on the surface in downward direction. Then as per Newton's third law of motion, surface will exert the force on block in upward direction, and that is called normal reaction. And when there is vertical equilibrium, it implies that in vertical direction, when there is no acceleration, then both these forces will be equal. Means N and mg will be equal. But in horizontal direction, when this force applied and the block is not moving, means horizontal equilibrium is also there. So definitely some other force is there, which one is in the opposite direction of this applied force, and which one is balancing this force. So which force is this one? That particular force is the frictional force. And that frictional force is between the surfaces which are in contact. Clear? And now see, here this particular friction or frictional force, that does not arise by itself. That is due to that external force. And here when under the effect of this friction, the object is stationary. So this friction is called static friction. And this friction is a self-adjusting one. As you increase the external force, it automatically increases, but up to certain maximum value. After that, if external force is increased, then body will start motion. Clear? And that particular limiting friction up to which the body remains stationary, and after that it start motion, that limiting friction is called maximum static friction. Clear? Static friction is such a force which opposes the impending motion. Impending motion means what? So impending motion means the motion which should be there in the absence of friction. But due to friction, it is not possible. So that particular motion is called impending motion. એટલે કે આપણે જે ફોર્સ લગાવીએ એના લીધે કરીને જે મોશન થવી જોઈએ પણ ફ્રિક્શનના લીધે કરીને થતી નથી. તો એ જે મોશન થવી જોઈતી હતી પણ થઈ નહીં, that is called impending motion. That is called impending motion. And friction opposes this impending motion. Clear? Now see, experiments shows this thing. The limiting value of static friction, that is the maximum static friction, that does not depends on the area of the surfaces which are in contact, right? But it depends on the normal reaction as well as the type of surfaces. So Fs maximum proportional to the normal reaction. So here we have to introduce one proportionality constant. So we can write Fs maximum, that is equal to mu s into n, where mu s is called the coefficient of static friction, which depends on the type of surfaces as well as temperature. Clear? So we can write the law of static friction, that is static friction is less than or equal to mu s into n. Maximum static friction is mu s into n. So rest, that is less than mu s into n. Okay, so it is self-adjusting. As you apply external force, this increases, but now we can say it will increase up to mu s into n. If your external applied force is greater than this value, then definitely now it will start motion. Clear to all of you?